Hi, I'm Teacher Zhu. I'm going to help you to solve questions from textbook, page 50, Formative Exercise 2.3. Okay, so question number 1. If xy minus 2x squared equals to 3, so we have xy minus 2x squared equals to 3. Show that x squared d squared y dx squared plus x dy dx equals to y. So now we need d squared y dx squared and dy dx. Okay, so meaning that you have to make y as subject. Okay, so here xy equals to 3 plus 2x squared, so y equals to 3 plus 2x squared over x. You can simplify this one, become 3 over x plus 2x squared over x. Okay, so therefore y equals to 3 over x plus 2x. Okay, this is our y. Okay, but to differentiate this one, you have to move x up. Okay, so this one we get y equals to 3x power of negative 1 plus 2x. So therefore you can differentiate with respect to x, become negative 3x power of negative 2 plus 2. Okay, or more proper if you express like this, negative 3 over x squared plus 2. Okay, so then for the squared y dx squared, you have to differentiate another time. So d squared y dx squared, differentiate another time, we get 6x power of negative 3. Okay, so all 6 over x cube. Okay, 6 over x cube. Okay, this is dy dx, this is d squared y dx squared. Okay, so from the question you have to show that x squared d squared y dx squared plus x dy dx equals to plus x. Okay, sorry. This one plus x dy dx equals to y. Okay, from the question here. Okay, you have to show this one. Okay, so then for this equation, you can substitute this squared y dx squared and dy dx. Okay, so here I substitute, become, okay, this squared y dx squared is this one, 6 over x cube plus x dy dx is this one, negative 3 over x squared plus 2. Okay, so then I expand, I get and simplified, I get 6 over x minus 3 over x plus 2x. Okay, then here is 3 over x plus 2x. Okay, so this one, okay, actually this one y equals to 3 over x plus 2x. So all this thing equals to y. All this thing is y. Okay, so therefore, we have shown. Okay, so this one shown. Number 2, given fx equals to 3x minus 2x cubed. Okay, the question asks you to find the value of x prime x, f prime 1, and f double prime 1 for each of the following function. Okay, so we differentiate. So f prime x equals to 3 minus 6x squared. Then we substitute f prime x equals to 1. 3 minus 6 times 1 squared is negative 3. Okay, so then here is the answer for f prime 1. Okay, so you have to differentiate another time. F double prime x is this one. Okay, negative 12x. So when x equals to 1, negative 12 times 1 equals to negative 12. B, given fx equals to x squared times 5x minus 3. Okay, for this kind of question, actually, we can use two alternative ways. Okay, the first one, you can use product rule. Okay, the second one, actually easier. If you expand, then you differentiate one by one. Okay, so then I want to expand this first. Become 5x cubed minus 3x squared. Okay, so this is fx, then I differentiate. Okay, become 15x squared minus 6x. So for f prime 1, I substitute 1, x is 1 minus, okay, so 15 minus 6 is 9. Okay, so differentiate another time. F double prime x is 30x minus 6. And when x is 1, so 30 minus 6, 24. For question C, fx equals to x cubed plus x over x squared. Okay, same thing. Okay, for this kind of question, you can use quotient rule. Or actually, you can simplify, then you differentiate one by one. Okay, I prefer simplify first. So fx equals to x cubed over x squared plus x over x squared. Okay, so then this one become x plus 1 over x. So therefore this one x plus x power of negative 1. This is fx. Okay, so then we ready to differentiate. Okay, f first derivative. Okay, 1 minus x power of negative 2. Okay, so then we substitute, or otherwise 1 minus 1 over x squared. Okay, so we substitute x equals to 1. So f prime 1 equals to 1 minus 1 over 1. Okay, so this equals to 0. Okay, so for f double prime x, second derivative. So here I have 2x power of negative 3. Okay, so all 2 over x cubed. When x equals to 1, okay, f double prime 1 equals to 2 over 1 cube, which is equals to 2. Okay, now next question number 3. Given fx equals to square root x squared minus 5 become x squared minus 5 power of 1 over 2. Okay, so this is a composite function. So you use power rule. Okay, so f prime x equals to 1 over 2 x squared minus 5 power of negative 1 over 2 times 2x. Okay, so we simplify. We get here x over x squared minus 5 power of half. Okay, power of half is square root. Okay, so x over square root x cubed, x squared minus 5. Okay, so then the question asks you to find f prime 3. Okay, so substitute x equals to 3. So f prime 3 equals to 3 over 3 squared minus 5 square root. Okay, so 3 squared 9, 9 minus 5 is 4, square root 4 is 2. So the answer is 3 over 2. Okay, this is the value of f prime 3. So you have to find another one, f double prime negative 3. Meaning that you have to differentiate another time and then you substitute x equals to negative 3 into f double prime. Okay, so from previously, this is x. Okay, this is our x prime. X prime is x. I rewrite. Okay, so f prime is x squared minus 5 power of negative 1 over 2. Okay, so then for this kind of question, you can use product rule, or you can use quotient rule if you express like this. Okay, so x over x squared minus 5 power of 1 over 2. If this one, you can use product rule. Okay, if this one, you can use quotient rule. Okay, so let's say I use quotient rule. So therefore I have to identify the u and v. Okay, so u here is ux, so du dx is 1. V is x squared minus 5 power of 1 over 2. So dv dx is 1 over 2 x squared minus 5 power of negative 1 over 2 times 2x. Okay, so here I get x over x squared minus 5 power of 1 over 2. Okay, careful. Okay, so this is quotient rule. So f double prime x is v du dx plus u dv dx. V first. Okay, so this one, oh sorry, over, sorry, minus, this one minus minus, okay, over v squared. Okay, so v first minus this one. Okay, so become x squared minus 5 power of 1 over 2 times 1. Okay, minus u dv dx, so x squared over x squared minus 5 power of 1 over 2. Okay, over v squared. Okay, this is v. So x squared minus 5 power of 1 over 2 squared. Okay, we can cancel off. Okay, so then this one, the value of x is negative 3. Okay, so then you substitute into the this expression. Okay, so f double prime negative 3. Okay, so negative 3 squared minus 5 power of 1 over 2 minus negative 3 squared over negative 3 squared minus 5 power of 1 over 2 over negative 3 squared minus 5. Okay, so this one, 9 minus 5 is 4 square root, power of half is 2 minus 9 over 2 divided by this one is 4. Okay, so then you press calculator, you get negative 5 over 8. Okay, so the answer is negative 5 over 8. Okay, come on, question number 4. Given A is t cubed plus 2t squared plus 3t plus 4. Okay, find the values of t such that dA dt equals to d squared A dt squared. Okay, so meaning that you have to differentiate twice because we have A in terms of t. We differentiate once, we get dA dt, okay, equals to 3t squared plus 4t plus 3. Okay, so d squared A dt squared, you differentiate another time, you get 6t plus 4. Okay, given this one, okay, given this one, dA dt equals to d squared A dt squared. Okay, so therefore you just equate these two. Okay, so 3t squared plus 4t plus, okay, wait, okay, given dA, okay, dt equals to d squared A dt squared. Okay, dA dt is 3t squared plus 4t plus 3 equals to 6t plus 4. Okay, this one is quadratic equation but not in general form. So you have to make it convert into general form. Become 3t squared plus 4t plus 3 minus 6t minus 4 equal to 0. So t squared minus 2t minus 1 equals to 0. Okay, this is quadratic equation in general form. So to solve quadratic equation, you can factorize. Okay, so here we get 3t plus 1. Okay, minus 1 equals to 0. Therefore, t is negative 1 over 3 and t equals to 1. Number 5, given the function gx equals to hx cubed minus 4x squared plus 5x. Okay, find the value of h if g double prime 1 equals to 4. Okay, meaning that you have to differentiate, find the second derivative. Okay, differentiate twice. So now given gx equals to hx cubed minus 4x squared plus 5x. Okay, so g prime x equals to 3hx squared minus 8x plus 5. Okay, so g double prime. Okay, differentiate another time. 6hx minus 8. Okay, so now given g double prime 1 equals to 4. So you substitute x equals to 1. So 6h 1 minus 8. So you equate to 4. Okay, so here 6h is 12, h equals to 2. Okay, just simple like that. The last one, question 6. Given fx equals to x cubed minus x squared minus 8x plus 9. Okay, so find the values of x such that f prime x equals to 0. Okay, so a f prime x. Okay, so you differentiate 3x squared minus 2x minus 8. Okay, so this one equal to 0. Okay, then this is quadratic equation, so you can factorize, become 3x x minus 2 plus 4, okay, equals to 0. So x equals to negative 4 over 3 and x equals to 2. Okay, so this is these are the values of x such that f prime x equals to 0. Okay, B. Find f double prime x. So from here, okay, you differentiate. Find the second derivative. Okay, so you get 6x minus 2. Okay, done. Okay, C. Find the value of x such that f double prime x equals to this 0. Okay, so this one equals to 0. 6x minus 2 equals to 0. So x equals to 1 over 3. Okay, so then D, find the range of x for f double prime x less than 0. Okay, so D, f double prime x less than 0. So f double prime just now 6x minus 2 less than 0. So x less than 1 over 3.